In this video, we'll be going over a physics and engineering analysis of a bicycle foot pump. The bicycle foot pump is used to take air at the inlet and move it to the outlet while allowing for pressure to build up in the device that is hooked into the outlet, which is commonly a bicycle tire. The foot pump consists of a pressure gauge which measures the pressure after the outlet, a piston that moves back and forth in the piston chamber to move air through the inlet or through the outlet, two check valves, one at the inlet and one at the outlet, which allow the fluid to flow, which the fluid in this case is air, one direction and does not let it flow the opposite direction. The direction of the flow is indicated by the arrow in the symbol for the check valve, and a spring that allows for potential energy to be stored on the exhaust stroke and kinetic energy to be released on the intake stroke. On the intake stroke, or when the piston chamber volume is expanding, the inlet check valve allows for the air to flow through, which allows the piston chamber to be filled with air. During the intake stroke, the outlet check valve remains closed. I would like to comment on the genius of putting the check valve on the piston, which allows for the check valve to be in an enclosed environment. This avoids the problem of contamination of the check valve. During the exhaust stroke, the piston is fully compressed and air is pushed out of the piston chamber and through the outlet check valve. The inlet check valve remains closed while the outlet check valve is open. The air through the outlet goes to the device you are trying to fill, and the pressure difference between atmospheric pressure and the outlet pressure is measured at the pressure indicator. When the pump is not in motion or at rest, both the inlet and the outlet check valves are closed. This allows for the pressure to be maintained at the outlet and keep contaminants from entering at the inlet. For this particular bicycle pump, it is foot operated and acts as a second class lever when going through the exhaust stroke. This means that the fulcrum is on one side of the lever arm, the resistance or load is at the middle, which in this case is the piston being compressed and the spring being compressed to store potential energy, and the effort on the opposite end, which is the force from the user's foot for compressing the bicycle pump. On the intake stroke, the class of lever changes to a third class lever. The fulcrum remains at the same location. The effort is now the spring, which changes the potential energy to kinetic energy to raise the lever arm. The load now is the resistance from the piston intaking the air. That concludes this video. Hope to have earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.